Good afternoon. My name is David Golds. I'm a lead program manager here in the File System and Storage team at Microsoft. I'm talking to you this afternoon about our storage snapshots for applying backup in Whistler. Really, there's one interesting problem with backup. We're trying to get the data off the machine and onto the backup media. And that's really that a program modifies files while they're being backed up. You can have a situation where you have the file contents when you start backing up the file. And in my example here is a simple message in a text file: blow up all the party balloons. Well, I'm going to back that file up. And let's say we get halfway through, so we get to blow up all the. That's great, my backup's going really well so far. But now, an application comes along and changes the file. In this case, it was the list of what to do when we shipped Windows 2000. Next thing they had to do on the list was provide a ship gift for the Windows 2000 team. They changed their file. The backup trundles on, continues to back up. And so now we have a backup which is neither the original file nor the later file. So unfortunately, we now have an instruction to blow up all the Windows 2000 team. And this would not be good. So clearly we have a problem with our backup. And really, this is a form of data corruption you have to be very wary of when making backups. And the issue here is really open file backup. When you have files, typically larger files, which are being backed up while some application is active, then really you need some way of managing and synchronizing that backup process. There are really 4 potential ways of solving this problem, and all have been applied at various times. One solution is to stop the applications while you're doing the backup. So I could close down my application, really make sure that nothing's running, do the backup, and then continue. And that's kind of how backup worked, and how it works in some places still. But it's not convenient, because we need to keep the systems running all the time now. The global web, and always a customer on the end of the wire waiting for things. There's no such thing as downtime. So stopping applications is really not a good scenario. Even in a desktop application, if you're starting to use terminal server, and you have 20, 30 people on a terminal server, you can start thinking, well, you have a problem, you can't tell them to just get off, to close down their apps, we're going to do a backup. Really, there is no downtime. So we move on. A different solution is just to skip the exclusively opened files during backup. Well, this is how backup applications typically work unless you buy extra pieces. If a file is opened exclusively so that somebody really cannot open it as well, then the backup applications will skip the file and put an entry in the log. Alternatively, if a file had been opened in a way that was for sharing, you can back up the file, but then you get the problem I outlined before, where you can get the file backed up at different points in time. So that's not ideal either. The next thing you can do is that each application can export explicit APIs for how to back it up. This has been done in the past in many situations. Many database programs, many mail servers, and often many services and operating systems expose APIs explaining how to back them up. In Windows 2000, for example, we have a multitude of APIs for backing up different stores, like the Active Directory, the Certificate Server, the WMI database, quite a host of databases. But then if you start adding to that the list of applications out in the world, and there are many, many thousands running on our platform, then trying to build APIs which generalize the backup problem can become very difficult. People have tried, it's been elusive. Now, another approach, which has been widely used in the past, is to take a snapshot of the data. So we provide some mechanism to really, on the whole set of data we're going to back up, take a snapshot, a point in time, which we define carefully. I'll talk about that later. And then we back up from that snapshot. It's like we hold time for a moment while we take this picture of the data, then we move forward and we back up the picture of that data, that snapshot. Now, many third-party backup applications have had an add-on for doing this in various ways. and they have various methods they use to define the point in time. Also, some people do this in hardware. EMC Time Finder is a good example of a system that uses snapshots in hardware. So before I progress too far, I want to clarify what is a snapshot. And really, we're defining here a snapshot as a copy of some data set at a point in time. And in Whistler, this data set here is a disk volume. In fact, it can be a number of disk volumes. And so really, we have a situation. Now, I have animations and sound on my slides, and you don't. So we write some data to a file at time t0. And at time t1, we choose to make a snapshot. And then we back up from the snapshot while the data is written to the disk. So that's the basic concept. We take the snapshot we back up from, and the other data is moving forward. So how does this work? There's two real ends of the way you do this. There's a real high-end solution, and there's a low-end solution. And as you can imagine, there are kind of in-between solutions. The high-end solution is really to start with the idea of mirrored disks. Start with two disks, mirrored, and really to make a complete copy of the entire volume. So I have my two sides of the mirror, and then really break that mirror into two. That's a snapshot, that's a point-in-time copy. And the idea is that then one half of that mirror you would continue to write to, and the other half of that mirror is now detached from the writes and becomes the thing you can back up from. The advantage of this is that in a high-end environment, this is a very fast process one split. It's just writing to the hard disk and you've made the copy. It takes some time to synchronize the mirrors, so there's an element of prepare time. And it is expensive, because you clearly have to spend on extra disk space. You're having to use at least twice the amount of disk space. And for that reason, it's considered currently a high-end storage feature. But the same concept really of a snapshot applies at the low end, using what's called a copy-on-write driver. And the idea here is don't copy everything. In this case, only copy the things that have changed since the snapshot. Because we have the original disk, and all we need to know is what changed, the sectors that were overwritten. Now, this can be done in a variety of ways. It can be done, for example, as a volume filter. That's a filter driver running below the file system, looking at sector changes. Or it could be done as a file system filter driver, implemented above the file system, keeping copies of files that change. Or you can do it in hardware, again, checking the sectors that change. It really works that you'd have some kind of sectors on your disk at the time of the snapshot. And when you make the snapshot, rather than copying data, it's an instruction to a driver or a piece of hardware to change behavior on subsequent writes. So we make the snapshot, and now there's new behavior when we write a sector. That behavior is that if I then write a sector on the disk, and here in this diagram I'm showing that on the second row as the circles in yellow. If those sectors are written, then in order to preserve my snapshot, my original point in time, I would have had to make copies of those original sectors. So my 0, my 1, my 3, 6, 7, 8, and 10 will be lost unless I've made a copy of them, which the snapshot driver needs to do. So it would copy the replaced sectors to a side store or a diff area. And there are many names for these things. A safe place somewhere in the storage system to keep these old copies of the files. And so the files that were overwritten, the sectors that were overwritten, we need to preserve in this side store. So now clearly we can access, read and write this main volume. But also if we want to have a representation of the old volume at the point of the time of the snapshot, then really we'd overlay the old sectors we squirreled away on top of the current view. So when I read sector 0, I know to look in my side store, because the side store is always the oldest copy of the file, of the sectors. By contrast, when I read sector 2, that wasn't in the side store, so I knew the version had not been superseded since the time of snapshot. So this is really a copy on write mechanism, and this is a way where a snapshot can be maintained by a driver or by a piece of hardware, and it only needs to keep a copy of the sectors that changed since the snapshot. If I go along and change sector 0 again, I don't need to store another copy of it in the side store, because I already have the oldest copy. And this is a fairly old technique. 30 years ago, this technique has been in use. So what are we doing about it here at Microsoft? Well, we want to make Windows a really great platform for snapshots. I'll talk about it later, but there's lots of applications of snapshots and lots of potential for them in the future. They solve an immediate problem for us, and so with backup, but they have lots of interesting potential moving forward. A number of companies spoke to us about the need to coordinate snapshots well on a platform, and the need to define points in time better, and the moment of snapshot, and the need to manage the snapshots once they exist. And so we've been building a common API and a coordinator to manage all of this. And we've been doing this in conjunction with a number of ISVs and IHVs who have been explaining to us their requirements. And really the idea here is that we want to help the Microsoft applications, the Microsoft services, as well as the ISV applications and the ISV stores participate well in a snapshot environment. Part of that is that we'll be providing an inbox snapshot driver, which is really intended to kind of seed the market, ensure that there's a lowest common denominator driver available, ensure that the concept is generally available from Whistler onwards. We actually chose the snapshots as more than just snapshots, but as the beginnings of a design paradigm for backup, because we gain a number of benefits. One nice thing about snapshots is that even if the applications do nothing to participate in the snapshot, then you still have an advantage in that we've defined the point in time, which is one point in time. So that problem I showed in that first slide, getting half of the file at one time and half of the file at the other time, won't exist. So you have an advantage even if you have no extra support from an application. You're defining almost what we call crash consistency, that the applications are the state as if the system had just been stopped at a point. And that's much better for recoverability than having some of the file written at some point in time and some of the file written at another point in time, and that being what we represent on tape. Another advantage of this method is that it works in the low end via software drivers, and as I said, it scales up to the enterprise. And also in terms of beginning a backup API for applications, you can build your backup application, your backup API inside your application incrementally, starting maybe with nothing, then adding a little more, and then adding a little more over time. But still, I want to emphasize that in terms of backup, there will always be some stores which have special APIs, because there are always certain cases, complex database configurations, complex mail system configurations, which will escape this general mechanism. There's a picture here which kind of shows really how this is holding together in Whistler. On the top right, we have what we call requesters, and these are the applications which are using the snapshots. They're actually requesting they are made, or requesting the access to one. Typically that means a backup application. So the requester, typically a backup application, asks for a snapshot to be created. In the middle, we have the snapshot coordination service, which is really talking to all the parties, doing the communication between these three classes of party. On the left-hand side, we have what we call writers. Writers here are defined as the things which write data to disk. Things like Exchange, SQL Server, Outlook, Oracle, all kinds of applications that write data to disk. And then in the middle of this picture and towards the bottom, we have snapshot providers, drivers or the software components plugging into hardware, which actually provide the snapshot service, provide this snapshot mechanism. And in the middle, that kind of green area in the middle, is a thing we call Lovelace, which is what's defining point in time. It's a collection of technologies and protocol between file systems and the drivers, which define the point in time, and very importantly, define a common point in time across all volumes. So a write-ahead log guarantee is preserved even across multiple volumes. That's very important for databases. So there's some elements here to go through. Providers, as I say, do the actual snapshotting. Writers are the applications which are writing to the disk. The snapshot service is this coordinator that's talking to all the pieces. And we have this idea of snapshot sets, allowing us to span volumes. And we can really create, enumerate, see, and destroy these snapshots through this service. There's really 4 sets of deliverables in Whistler. One very important one is we have a level of application and file system synchronization across volumes. There are 2 elements of this. One part was Lovelace, which I described before. Another part is that we have these freeze and thaw APIs we're exposing for applications so that they can participate in the moment of snapshot. When we create the snapshot, we send these messages to those writer applications which are subscribing to these events, allowing them to define for themselves this point of snapshot. And we're evangelizing this API to these applications internally in Microsoft and externally via ISVs. Second piece is our coordination. This whole snapshot service, which really has no state of its own. It's just talking to all the parties. It's the glue holding this together. And it talks to multiple providers, multiple writers, and even has a way in the future on a storage area network of finding these snapshots, even on a SAN. That's not really a key scenario for Whistler, but moving forward, it's important to know that the architecture is there supporting it. The third element is this interface with providers, so that companies with hardware or companies with software snapshot engines can plug in and gain our synchronization of applications and our carefully defined synchronization of the point in time across volumes and the flushing of the file systems. And our inbox snapshot driver is very limited, just is intended for the key backup scenario. Read-only snapshots, which disappear upon reboot, and one on a volume at a time. ISVs and IHVs can exceed these constraints. They are just constraints in our base driver. This is all we fundamentally need for backup scenarios. And finally, NT backup will use snapshots to snapshot multiple volumes, and if the snapshot fails for some reason, it can still revert to the non-snapshot mechanisms. And in fact, snapshots is the beginning of another talk, because really, the snapshot interfaces, the applications, can just say we're making a snapshot, but they also have extensions for allowing applications to register where their data is, and also to participate in a restore framework. So snapshots is also a beginning of a much wider way of making applications backup friendly. That's the end of my talk, so I think we now have time for questions. So I have no questions yet, so I always explain fundamentally clearly. I'll give you a few moments, see if there are any questions coming. No, I'm not from New Zealand, I'm from England. Thank you. Okay. Well, I think that's obviously been clear. There'll be more information coming through later in the Whistler program. And of course, you can contact me directly if you have any further questions. So thank you for your time.